So tonight's video is kind of like Monday's video in that I'm just going to lead you through some of the questions on the two sheets that I would like you to work on this weekend. So those two sheets look like this sheet with this little funny looking guy up there, okay, perimeter and area, and this sheet. Now, the first sheet is in your practice packet. This is in your practice packet. And the second sheet with the shaded areas is in the notes packet. I apologize about that, but you just have to use both packets tonight, okay? You're going to be doing the odds. I'm going to show you what I would like from a couple of the evens, okay? It's pretty straightforward, but I just want you to see what I'm expecting to see here, okay? So for number 2, this is strictly perimeter. And I would want you to, again, use your formula. So you either have to say sum of all sides, or twice I'm going to use length plus width here. Okay, and this is going to be, these answers are going to be algebraic expressions. You are not going to get an answer. You're going to get an algebraic expression here. So my length is x squared plus x plus 2. And my width then is going to be 2x plus 6. And then I need to simplify that by combining like terms. So my x squared is all alone. There's nothing to combine x squared with. My x can be combined with the 2x, and the plus 2 can be combined with the plus 6. So that's going to simplify and give me 2 times x squared plus 3x plus 8. And then we distribute the 2, and the perimeter is going to give me 2x squared plus 6x plus 16, and that's units. They don't give us units here, so just to be in the habit, you should just write a U. Pretty straightforward. I would say in a question like number 2, I would probably use sum of all sides because there's really no shortcut there. In a question like 6, I would use 5 times s, and then I would just multiply 5 times that expression. Okay? And there may be some harder ones for you to think about, like number 10. But this is kind of like some of the questions we've done previously, where you just have to figure out that missing part. So I know that this is a square, so that means that this side has to be 3a like this side, which means that each of these sections are 1.5a. Okay? Because I don't want to take this part of the square when I'm figuring out the perimeter, because really I want the perimeter of this thing going like this. All right? So you need to be careful to just be working on those sections. And here again, I would use sum of all sides. All right? So I think you should be fine with that. Now on the back, they want the area. Okay? So again, these are irregular shapes, and you're going to come up with an algebraic expression. So here, I like to think of this maybe as two different figures, A and B, and I might do area equals area of A, okay, plus area of B. And then I know that the area equals side squared plus, it's another square they tell me, side squared, and one is of A and one is of B. So my area is going to be y squared plus x squared. And if I wanted to write that in standard form, that would be alphabetical. So x squared plus y squared, unit squared. That's going to look kind of crazy, but that's the answer. Okay? Let's see. Actually, I don't think you can do number 13 because that's a binomial, or 15. But you should be fine with 11. So, yeah, you can just skip those now that I look at that. Okay, so you only have to do number 11 on the back. You got lucky. Moving on to the second sheet that I would like you to work on. The first thing I notice is there's an error here. It goes 1, 2, 2. So I would like you to change this to a 3, which means this is one of the problems that you will do along with 1 and 5 and then some on the back. But let me go over one of these questions with you. The thing with these is you might dissect your particular shape differently than someone else. The one thing you want to be careful of is you want to be sure that you're using the given information to kind of strategically dissect your information. So for instance, you want to make sure that you have the necessary information that you need. I'm going to look at number 4. And if I look at that, there's a lot of ways I can chop that up. I could go like this. Okay, and I would have a trapezoid, and a trapezoid. Or I could chop it into little tiny pieces. I could go like this and like this. Then I would have a triangle and a rectangle and a rectangle. All right, I happen to do it even different than that. I did use this triangle here, and then I created a line there. Why? I have no idea why. Doesn't really matter. All right. This, I hope, on your paper is 120. If it's not, why don't you go ahead and change that? I'm not sure if I changed that. And then this is 40, so this is 5,200, this area. And I will maybe write those in there, or I would put, like I did before, like an A, and I would go area of A equals length times width equals 120 times 40 equals, that wouldn't be 5,200 though. 12 times 4 is 48. I think we might have changed this problem. So let's just assume that that's the 120, and 12 times 4, as I said, is 48. So that'd be 4,800. And I would write that in there. And then I would do part B, and that would be 50 times 70. So I would do 50 times 70, and that's 3,500. And then I have 1/2. Area of C is 1/2 base times height, which is 1/2 of 80 times height there. You have to figure it out, okay? So it's going to be 60 plus 50 plus 40. So that's 80 times 150, and that's 40 times 150, which is 6,000. And then the final area, you could do like area sub T for total equals area of A plus area of B plus area of C, and that's going to be, I think 14,300. I have 2 answers here. I'm not going to worry about it right now because I think you guys get the idea. So you're going to work on 1 and 3, chopping those up as necessary. And the shaded region, I'm going to let you play with that. I think you're capable of that. And then some review problems on the back. So go ahead and take care of 7 and 9. See what you can do. I'd like you to try your best. And actually, why don't I do 9 with you? If you want to try it on your own, that would be fine. I'm going to show you how to do 10 rather, not 9, because 10 is like 9. So the length of a rectangle exceeds the width by 4 meters. We're used to doing this. So the length is going to be the width plus 4, and this is my width. Now I'm going to get a new rectangle. This is my original rectangle. Okay, I'm going to get a new rectangle. And the width is doubled, so it's going to be 2W, and the length is diminished by 2. So it's going to be W plus 4 minus 2, which is actually W plus 2. Okay, for that length. A new rectangle is formed whose perimeter is 8 meters more. So this perimeter is 8 meters more than the other one. Okay? So what is the perimeter here? The perimeter here is going to be 4W plus 8. Okay? And the perimeter here, that's my original. The perimeter of the new is going to be 2W plus 2W plus XW plus 2 plus W plus 2, which is 4, 5, 6W plus 4. And I know that the perimeter of the original perimeter is 8 meters more. Okay, so 6W plus 4 is 8 meters more than the original one. Okay, so that's going to be 6w plus 4 equals, oops, that's a 4, w plus 16. And if you solve that, you should get x equals 6. Or w, sorry, I have x on my paper, so I'm kind of varying back and forth here. So then what do they want to know? The dimensions of the original. So this would be a 10 by 6 meters. Okay? That would be your final answer. So that's kind of how you do this original new thing and set it up appropriately. Okay? So you're on your own now, and we'll discuss those odds on Monday. Have a great time.